So let's talk about the different kinds of communication, the different patterns of communication you'll see in parallel computing. And as you'll see, this is really all about how to map tasks and memory together, how to map tasks, which are threads in CUDA, and the memory that they're communicating through. So the communication pattern you've already seen is called map. Now with map, you've got many data elements, such as elements of an array, or entries in a matrix, or pixels in an image, and you're going to do the same function, or computational task, on each piece of data. This means each task is going to read from and write to a specific place in memory. There's a one-to-one correspondence between input and output. So map is very efficient on GPUs, and it's easily expressed in an efficient way in CUDA by simply having one thread do each task. But this isn't a very flexible framework. There's many things you can't do with a simple map operation. Now suppose that you want each thread to compute and store the average across a range of data elements. Say maybe we want to average each set of 3 elements together. In this case, each thread is going to read the values from 3 locations in memory and write them into a single place, and so on. Or suppose you want to blur an image by setting each pixel to the average of its neighboring pixels, so that this pixel would average together the values of all 5 of these pixels, and then let's take this pixel next to it would average together the values of all these pixels, and so on. We'll do exactly this kind of blurring operation in the homework assignment that's coming up at the end of this lecture. This operation is called a gather because each calculation gathers input data elements together from different places to compute an output result.